All right, so we're graphing transformations. Hopefully I didn't misspell anything or anything weird up here, but we're gonna just talk about how to graph transformations by hand and what that looks like. So our objectives are to graph functions using vertical and horizontal shifts, to graph using compressions and stretches, and graph functions using reflections about the X and Y axis. All this should somehow ring some bells and sound familiar, seeing how you should have did it in Algebra 2 for every single function, every unit. So hopefully it goes fairly smoothly. So we're going to start off with functions using vertical and horizontal shifts. So when you are transforming, you have a transformation function formula. And so we talk about H and K and what H and K's role are. So if I have an H is my horizontal transformation. If I have a K, that is my vertical transformation, okay? A positive K means I'm going up and down, and a negative H actually means I'm going to the left. Right, I said left, my bad. No, it's inside. So what is it? They didn't change the thingy. This should be a little plus sign on your 4. I apologize. Does the 4 not have a plus sign? My bad. So your 4 should have a plus sign because our X's are liars. So if we remember that, then that helps us with as far as the transformation. So your X's are liars. So if it looks like a minus, it's actually moving to the right. If it looks like a plus, it's actually moving to the left. It's the opposite of what's happening, okay? Sorry that the 4 plus sign was not there, but hopefully you put the little line so that you won't be confused later. Vertical shifts, again, just remembering that vertical means you're going up or down. So how does that work graphically? And again, this is all about doing everything by hand. We're kind of taking a step back from the calculator. So graphing it by hand. Is this page missing? No. Oh, I was like, what? All right. So our first thing we have is a vertical shift down. The reason why we know it's a vertical shift down is because we have our function, and then there's something being added or subtracted to the function. Okay, does that make sense? All right, so for square root, the whole transformation would look like this. If I had a square root of X minus H plus K, right? And so that's how that would look in general. But here we have our K and it's a negative K. So what that means to the table is that my X's stay the same. So your parent function X values are going to stay the same. However, to each one of your new functions, you're adding, subtracting 2 to find its value. So on this one, we are subtracting 2. So we're going to start off with the parent function because everything starts with the parent function. And our parent function values for the square root of X. Hopefully you guys don't freak out because you did your projects, right? So when I write these, it should be like, oh yeah, I knew that. So we have 0, 0. We have 1, 1. We have 4, 2. We have 9, 3. We have 16, 4. We have 25, 5. And we have 36, 6. Do we understand why those are the parent function values for the square root function? Yes? Okay. Now, to each one of my y values, I'm now doing what? Subtracting 2. Am I touching the X values?
No.
No, because vertical translations only affect the y. So I have 0 minus 2, which is going to put it at negative 2. So this new point is at 0, comma, negative 2. Does that make sense? Okay. I have 1 minus 2, which is going to put that at negative 1. So this point is at 1, negative 1. I have 4, 2, but I'm subtracting from 2. 2 minus 2 equals 0. So this point is now at 4, comma, 0. I have 3 minus 2, which is 1. So we're at 9, comma, 1. I'm going to keep going, though I won't be able to graph the rest. Just want to make sure you see what's happening and how creating the table works. And then we have 6 minus 2, which is 4. And we would be at 36, 4. Okay. Questions about what we did for a translation down? No? So when I plot these, I'm going to go to 0, -2. I go to 1, -1. I go to 4. 1, 2, 3, 4. 4, 0. And I go to 9, 1. 5, 6, 7, 8, 9. Hopefully you're not looking at me for plotting because you can count and plot on your own. And there's my transformed square root function, shifted down 2 units. So the domain of this function is x is what? Greater than or equal to 0, right? Or I can write it from 0 to infinity. Yes.
I don't remember what the parent thing when you use or the brackets when you.
So brackets is if there is a value there. So if there's a value for 0, then so 0 has a value. 0 is at -2. So if there's a value, that's a bracket because it's closed, it's included. Parentheses means I have a hole, a gap, an asymptote, or it's infinite. Okay. So then my range here, what is my lowest y value? -2. So y is greater than or equal to -2, or I can write it as -2 to infinity. Questions about a vertical shift down? Good? Okay. So for vertical shift down, sorry, I'm gonna repeat, it would be the same process if it was a shift up. Instead of subtracting, you would do what? Adding. Are we good? Okay. So now we're gonna talk about horizontal shifts. So for horizontal shifts, that means you're going to the left or you're going to the right. Key thing remember is that even though it looks like it's a minus, it's actually a positive and you're moving to the right. Even though it looks like a plus, it's actually a minus and you're moving to the left. Okay. So here, we're going to combine. We're going to do a little adding and subtracting on the x and on the y. Is that okay with you? Okay. All right. So we have graph the function f of x equals x minus 3 squared plus 2, and then find the domain of it. Okay. So when we are graphing this, we have x minus 3 squared plus 2. We have a couple things happening here, right? We have an h and we have a k. H is going to affect my x and k is going to affect my y. Does that make sense? So we're going to be doing 2 things. Now, first thing as always, you start with the parent function. Okay. What was the parent function of this? The parent function here is just squared, the quadratic. So the parent function is f of x equals x squared. That's my parent function. Okay, so for the parent function of x squared, and you're starting off with values, we're just going to start at -3. How about that? If I start at -3, -2, -1, 0, 1, 2, and 3. Sorry, can y'all make this an H so that it fits our table? Okay, so our original parent would be, what is -3 squared? 9. What is -2 squared? 1. -1 squared. 0, 1, 4, 9. Agreed? Those are the values of our parent function. Anyone's not understanding where those values came from? Okay, now we're going to make some transformations. Okay, in this column here, I need you guys to split it for me. because this time we're changing our X's and our Y's. Does that make sense? So we're gonna have to make changes to the X's and changes to the Y's. It doesn't really matter which side you put it on. So X, how are the X's being affected? +3 to each X. Because even though it looks like it's a subtraction, it's actually a plus. Got it? And then what's happening to my Y's? Y is what it is. Why lie? There's no need to lie. Just plus the 2. So -3 + 3 is what? -3 + 3 is 0. So all we did was -3 + 3. Yeah? For the Y, so we have 9 + 2. What is that? Do you see what's happening? So I'm gonna do these to all of the values on the way down. Okay? I'm gonna do it in my brain because I want you to do it and not depend on my words.
Ms. Jones, did we do this before? This back? Did we do this years ago?
No, we've just learned this material.
I feel like you did this back.
We didn't.
You did.
We did it. No, I'm saying we did it. I don't hear what she said. Oh, no, but this should feel very familiar. Like this should not be like, oh my gosh, I've never seen this before. Huh? All right, how do we feel? And then you plot the points. So 11 doesn't fit, so I'm not gonna be able to put 11 on here, but can I do everything else?
Yes.
Yes. I could be extra and go up 1. It's not gonna kill me. There we go. 2 is at 3. 3 is at 2. And then we're gonna mimic it. Okay. All right. How do you feel about vertical and horizontal transformations combined? Is it a doable situation? And like Libby pointed out, this should almost feel like you're duplicating something you've done before. Guess we did it in our quadratic unit. All right. If it changes, what if I had the absolute value function? What if I had the exponential function? Would any of this process change? No, the rules stay the rules, okay? Your H is gonna make you go left and right. Your K is gonna make you go up and down. The rules are gonna stay the same no matter what your function is. Does that make sense? Okay. All right, now we're gonna talk about compressing and stretching, okay? So for compressing and stretching, when you have a vertical compression, we call that our A. Well, our A value is what we focus on. So that's our A value in front, our leading coefficient, right? Our leading coefficient, that tells us what's happening. If A is between 0 and 1, it's a vertical compression. Okay. In some books, they may call it a shrink. But it's a vertical compression. Okay. If your A is greater than 1, we stretch by that factor. Okay. When we're looking at A, we're keeping in mind that it's just the absolute value of A. We're not talking about whether it's negative or positive. We're just saying, where does it lie between 0 and 1 or greater than 1? Okay. So again, a vertical stretch, that means that you're working out more, right? If I work out more, I'm going to stretch out, right? If I work out less, it's going to get a little wider, a little crumpled in, right? That's how I visualize it in my brain. All right. So then the horizontal goes this way. That's like playing, what's that instrument called? An accordion. Yeah, that's what it's called. So it's the opposite on the accordion because your X does everything opposite, right? So if your A is greater than 1, you are compressing. You're putting more pressure. I'm applying more pressure to it, okay? If your A is between 0 and 1, you're releasing it. You're applying less pressure, so it's getting wider on the axis, okay? And I guess this is where we'll pick up. Tomorrow, come ready to take your BOY. Our beginning of the year assessment. I'm sorry.